The next section that we're looking at is dividing polynomials. Before we actually get into the advanced functions portion of it, I want to go back to when we actually learned about long division and review some of those skills, because that's what we're going to be applying to our polynomials in order to divide them effectively. So the first question we're going to have is 249 divided by 4. So there's your long division sign. We put in our number, 249, and we're going to divide this number by 4. First step is we look at the 2. Can we take 2 and divide it into 4 parts and maintain whole numbers? No, we can't. It would turn into decimals. So we're going to ignore the 2 and extend our line to include 4. So now we want to know, can 24 be divided into 4? And yes, it can. 6 multiplied by 4 will give us 24. We subtract that. 24 minus 24 cancels out. Then we bring the 9 down. And we put the 9 here. Now we think, can 9 be divided into 2? To figure that out, you find the largest multiple of 4 that is still less than 9. That would be 8. So we put a 2 here. 4 multiplied by 2 is 8. Leaves us with a remainder of 1. That's it. That is long division. What we have done is exactly what we'll be doing with polynomials. Before we move on, I want to go ahead and review a few things. 62 is what is known as the quotient. 249 is what is known as the dividend. 4 is the divisor. And 1 is the remainder. It's important to know what these things are. The quotient is just the answer to a division question. 4 is the divisor. It's the number that you're dividing by. It goes on the outside of the division symbol. The dividend is the amount that's being divided into smaller parts, and that goes inside the inside the division symbol. And 1, the remainder, is what's left over after you have done the full division. Another way to understand, another concept to understand is how do we present our answer. So 249 divided by 4, there's 2 different ways. One would be that it is 62 with a remainder of 1. The other way is to write 62 plus a quarter. You have 1 left over out of 4 parts, so it's 62 plus 1 over 4. These are different things that we have to understand. The process is straightforward. You look at what is the smallest amount that you can divide first, and then move on from there. Let's go ahead and apply this to a polynomial equation, shall we? The next question we want to look at, again with polynomials now, is 3x cubed minus 5x squared minus 7x minus 1 divided by x minus 3. Once again, there is your dividend. This is the amount that's being divided. That's your divisor because that's what we're dividing by. Let's go ahead and put this into our long division format. By the way, we are going to show you how to do division in 2 different methods. One is the long division method, which I'm starting now. And the second will be something called synthetic division, which we'll get to afterwards. So the first method, 3x cubed minus 5x squared minus 7x minus 1, also known as dividend, goes inside the long division symbol. The x minus 3, which is the divisor, goes on the outside. First step, we have 2 terms here. So to divide, if we were to do 3x cubed, you could not divide it into x minus 3 because you need to have 2 terms. So we're going to extend. The first thing we're going to divide will have these 2 in it. X minus 3 is what we're dividing by, so we need 2 terms from our dividend that we're going to divide. How many times can x minus 3 go into 3x cubed minus 5x squared? The easiest thing is to take the first terms and divide. So we would look at 3x cubed and divided by x. 3 divided by the 1 is 3. X cubed divided by x is x squared. So the division here, the factor that we're going to put up at the top is going to be 3x squared. Remember, we want to try to match. This is 3x squared, so we put it on top here. Now we multiply 3x squared by all of this. 3x squared multiplied by x is 3x cubed. 3x squared multiplied by negative 3 is negative 9x squared. What's your next step? We want to subtract. So in order to subtract now, what we're going to do is, so we have negative 5x squared minus 9x squared. So minus a negative 9x squared, sorry, which makes it plus 9x squared. Make it 4x squared. 3x cubed minus 3x cubed is 0. So we have 4x squared, then we bring down the 7x. Now, before we go on, let's review this again. 3x cubed minus 5x squared to determine what the number, the number that goes into our answer, the term that goes into our answer, going into our quotient. We'll take 3x cubed divided by x. 3 divided by 1 is 3. X cubed divided by x is x squared. So 3x squared goes at the top. Now we take that number from our quotient and multiply it by our divisor to figure out what term goes at the bottom. 3x squared multiplied by x is 3x cubed. 3x squared multiplied by negative 3 is negative 9x squared. Next step is to subtract. 3x cubed minus 3x cubed is 0. Negative 5x squared minus a negative 9 becomes plus 9x squared. So negative 5 plus 9 is positive 4, and then the x squared just comes along. Same process. Now we're going to repeat all of this here. How many times can x go into 4x squared? We'll have 4x squared divided by x. 4 divided by 1 is just 4. X squared divided by x would be x. And then we're going to do plus 4x. Same thing. Let's take the 4x and multiply. 4x times x is 4x squared. 4x times negative 3 minus 12x. And now we subtract. 4x squared minus 4x squared is gone. That's 0. Negative 7x minus a negative 12x is negative 7x plus 12x. That gives us 15x. And we bring down to minus 1. And we have that step. Repeat. How many times can 15x go into x? Well, 15x divided by x would just be 15. If we go through multiply, 15 times x is 15x. 15 times negative 3 is minus 45. And now we're going to subtract these. 15x minus 15x is 0. Negative 1 minus a negative 45 is now negative 1 plus 45, which gives us 44. So our entire answer, the quotient to this question, would be 3x squared plus 4x plus 15, and then the remainder. So our final answer will be 3x squared plus 4x plus 15 plus 44 over x minus 3. There is our quotient. The long division may seem tricky at first, but once you do a few examples and you go through the examples slowly, don't try to rush through it, you'll pick up on the little things that you need to know, and then it's just a repeat. It's a repeat, rinse, repeat over and over again. That is long division. Let's do the same question using a method known as synthetic division. There are some rules for when you're allowed to use synthetic division. The long division method can be used in any polynomial division question. The synthetic division method can only be used if the divisor, the term that you're dividing by, is linear. So if the divisor is linear, we can use another method called synthetic division. So for synthetic division, the division symbol flips. What goes on the outside is the factor. So when it comes to x minus 3, the factor would be x equals 3. So the factor 3 goes on the outside. And then what goes here are not the whole terms, but just the coefficients. So 3x cubed would be 3. Minus 5x squared would be negative 5. Minus 7x would just be negative 7. And then negative 1. By the way, you'll find that this method, synthetic division, is a lot faster, it's a lot simpler, it's a lot cleaner than the longer polynomial division. So in majority of the cases, if you have a linear divisor, strongly recommended to use synthetic division. Process for synthetic division. The 3 comes down, we'll put it here. Now we take 3 multiplied by the term on the outside, which is also 3, becomes 9 here. And now instead of subtracting, we're going to be doing addition. So negative 5 plus 9 is positive 4. 4 multiplied by 3. 12 goes here. Negative 7 plus 12, positive 5. 5 multiplied by 3, 15. Negative 1, sorry, 45. Negative 1 plus 5 multiplied by 3, 15. Negative 1 plus 15 would be 14. And there would be your answer. What do we put for our answer? This was x cubed. So the next one, because you're dividing by linear, would be 1 less. So it becomes 3x squared plus 4x plus 5 plus 14 over x minus 3, because that's your remainder. And that would give us the same thing. And now looking back, I realized when I was doing long division, I made a mistake. I did 5 times 3 and I got 45, where I think I may have put a 15 in there somewhere. So that's a mistake. This should have been 14 over x minus 3. This is synthetic division. You now have seen both methods of doing polynomial division or dividing polynomials. It's important that you are comfortable with both, because doing the synthetic division method clearly will save you time, and it's much more efficient, it's much cleaner, there's less to look at, less opportunity to make mistakes because there's less things being written down, but it cannot be used in all cases. So make sure you're comfortable with polynomial long division and synthetic division. Now let's take a look at a few more examples to see what other kinds of questions we can get. Alright, so the next question, determine whether x plus 2 is a factor of 13x minus 2x cubed plus x to the power of 4 minus 6. There's something that we need to make sure that we understand before we get into this question. That is, what does it take for something to be considered a factor? So if I ask you what are the factors of 12, you tell me 1, 2, 3, 4, 6, and 12. Right, these are the numbers that if you were to take 12 and divide by any of them, your remainder would be 0. There would be nothing left over. So a key to remembering, if something is considered a factor, the remainder must be equal to 0. If you can show that the remainder is 0, you have shown that it's a factor. If the remainder is anything but 0, that means it's not a factor. There's something left over. So let's go ahead and divide these and see if we get a remainder of 0. Because I am dividing by a linear function, x plus 2, I will be using synthetic division. So negative 2 goes on the outside. Now for this, I'm going to put these in descending order, starting with the largest exponent. So x to the power of 4, that's a 1. X to the power of 3, that's a negative 2. And then it goes to x. However, I cannot go to x. When I have x to the power of 4, I need to include every single exponent less than 4. So I have 4, 3, I need to show x to the power of 2. There is none, so that's 0 x to the power of 2. Then there's 13 x's, and then there is a negative 6 for x to the power of 0. Now we go through and do synthetic division. The 1 comes down. 1 times negative 2 is negative 2. Negative 2 plus negative 2 is negative 4. Negative 2 times negative 4 is 8. Would be 8. 8 times negative 2 is negative 16. 13 minus 16 is negative 3. Negative 3 times negative 2 is positive 6. And then negative 6 plus 6 is 0. Because we see that the remainder is equal to 0, therefore x plus 2 is a factor. And that is how you would find factors. Before we end, I do want to reiterate again. Any question that you have, any term that you have, whether it's the divisor or it's the dividend, One, you always write them down when you're doing division in descending order, meaning from the largest exponent to the smallest exponent. And two, you must include every exponent. So if it was x to the power of 3, do you know you must have 4 terms? X cubed, x squared, x to the power of 1, and then when the number is by itself. And if any of these are missing, it just means that you have 0 of them. So you would, instead of putting 1x squared, you should put 0x squared. So this equation here, x to the power of 3, negative 2x to the power of, x to the power of 4, negative 2x to the power of 3, 0x squared, 13x's and negative 6. And now that's the equation that we would use. Thank you, and I'll see you next time.